The purpose of this video is to talk to you about variables and exponents as we start on our journey into algebra. We're going to talk about some key terms which you can see written below. We've got variable and constant, so we'll talk about what those mean. And then we've also got numerical expressions and algebraic expressions, and what are they? So let's start with a variable. A variable is a letter in a mathematical equation or expression that represents something unknown. We generally use letters such as X or Y, or it could be any of our 26 letters in the alphabet. Good thing to note, if we're using X as a variable, you're probably not going to want to use that for multiplication anymore. But basically, as I said, variables are letters that represent something that we may know, we may not. A constant is basically something whose value doesn't change, like the number 5. 5 is always worth 5 of whatever. Same thing with 7. Constants are numbers. Okay, they're not variables. Variables can change. Y could be 2 or Y could be 6. But 5 is always 5. So those are our first two terms, variables and constants. Variables are a letter that represents some unknown value. Constant is a number that does not change. That moves into our numerical and algebraic expressions. Now they both end with the words expressions. That just means there is not going to be an equal sign. It's just going to be numbers, possibly variables, and an operation such as addition, subtraction, multiplication, or division. A numerical expression, let's scroll this up a little bit. Numerical expression is something like this: 5 plus 2. Or it could be something like this: 7 minus 3. In a numerical expression, you have constants, 5, 2, 7, and 3, those are all the constants, and you have an operation. Operation being addition and subtraction here. It could also be multiplication, so you could have 6 times 4. That would be a numerical expression because you are using constants and an operation. And it could also be this: 7 plus 3 minus 2. I used more constants this time, but this whole expression is only made up of constants and operations. So those are numerical expressions. Algebraic expressions are similar. The main difference here, we are going to have a variable. So it could be 7 plus x. We don't know what x is though. So keep that in mind. Here, we could eventually solve these and turn them into an equation. Until we know what that x stands for, we can't do anything with this. It could also be x divided by 2. That would be an algebraic expression as well. Algebraic expressions use constants and variables and operations. Okay, it doesn't have to use all of them, but it could. An example that only uses variables would be if we had, say, x minus y. This is still an algebraic expression because it is using variables and it's using an operation, even though no constants are involved. So there's part 1 of our video for variables and expressions. Now, let's talk about how to read or how to translate expressions involving variables. Here we have 2 algebraic expressions. And while we can look at it and know what it's asking us to do, sometimes we want to translate it into words. Say if we are trying to describe it to someone who has never seen this before. One way we could do this is by saying, oh, x plus 3. It describes what's happening in our algebraic expression, and the important thing is we are correctly identifying the operation with plus. We could also call this, though, the sum of x and 3. And I wrote the number 3 there, but it could have been the word 2. That isn't as big of an issue. But we use the word sum because, remember, sum is part of a addition operation. That is the answer to an addition problem. So take a look at this one over here. Can you think of one or two ways on how you would write or translate this into words? Hopefully you're thinking to yourself, well, one way we could say is m minus 7. We're using our variable m and our constant 7, and instead of saying the subtraction sign, we're saying minus. What is another way that we can say or imply subtraction, though? Or what is the subtraction version of the word sum? Well, that would be difference. So we could also say the difference, the difference of m and 7. And it's important with subtraction that if we're using this version, that we make sure the m goes first and the 7 goes second. Okay, now let's see how it translates to word problems. With word problems, it is up to us to identify in the problem what words imply addition or subtraction or multiplication or division. So hopefully, if you're watching this, you've seen word problems before and been able to decide, oh, in this problem I must be using addition or I must be using division based on the wording. With addition, you might see the words sum or plus, or in some cases you could see the word combined. All of those would imply addition. So if we were to see those in a word problem, it means we're probably going to use addition. Same thing with subtraction. We could see the word minus or difference or take away to help us realize in this problem we are going to need to use subtraction. Now, these aren't the only words we could see for addition or subtraction. There's tons. These are just some examples. If you see something that talks about, oh, someone being younger and trying to figure out their age, that might involve subtraction as well. For multiplication, you could see the word by. That implies multiplication sometimes. Same with the word per and product. Product being the answer to a multiplication problem. Lastly, for division, you could see ratio or quotient. Or if the problem is involving two quantities or a variable and a constant, and they're trying to find a relationship between them, I don't have a really good word to put for that, that could imply division as well. So it's basically, you need to read them carefully, see what the problem is asking, and then try to come up with something that makes sense. Okay, now, last bit that we're going to do. Taking some algebraic expressions and actually trying to solve them. Here's an algebraic expression. Remember, it's an algebraic expression because we have variables and an operation. Even though there's no constant, the fact that there's variables there makes it algebraic. Now, if I'm saying a plus b, the problem is I can't do this if I don't know what a is and I don't know what b is. Thankfully, the problems we're going to be working on, that'll have to tell us, hey, a equals 5, b equals 7. And then we can solve this, because in a variable, it can stand for any value until we know exactly what it is. A is 5, so instead of putting a there, I can rewrite this as 5 plus, now the same thing with b. Now that I know what b is, instead of having a plus b or 5 plus b, I can say b is 7, so I can put in a 7. And then we can solve it. What is 5 plus 7? 12. So in this instance, if a is 5 and b is 7, it ends up to be 12. And this can change. Let's say instead of a being 5 and b being 7, now a is 3 and b is 20. Well, I'll do the same thing as before. I'm going to substitute 3 for a plus 20 for b, and then I can solve them by adding them together, which gives me 23. And this doesn't just work with addition, it would work the same way with any of our operations. So let's say instead of a plus b, we have, I don't know, c times d divided by e. Okay, it's written as a fraction, so that's going to mean that we're going to have to do some division. Now, just like before, I can't do anything with this until I know what c, d, and e are. Thankfully, I'm going to tell us c equals 4, d equals 5, and e equals 10. Now that I know my three values, just like before, all I have to do is rewrite this with the values substituted in for each piece. So c is 4, so I have 4 times d, which is 5. I'm trying to color code it here, divided by e, which is 10. And we can go about solving this. What's 4 times 5? Well, that's 20. And what's 20 divided by 10? That's 2. So there we have it. This is our intro video to variables and expressions. Hopefully we have a little bit better of an understanding with them and we can be successful in solving these. Good luck, and I hope you enjoyed it.